So unfortunately, you didn't have this question in your notebook, but it was sent to you so you could print out and do ahead of time. So the graph of this function consists of 3 line segments, a quarter circle, and let g be this function. So notice they gave you g to be this function and f to be this function. So we do have to keep things straight. Are we talking about g or are we talking about f? In part A is usually where kids have the most mistake on this question, and you probably know exactly what to do, but again, watch that function. Our key calculus term is average rate of change, so you should be feeling really good. But now of who? Who are they asking you to do this to? And notice they're asking of g. So don't write f of b minus f of a. It should be g of 5 minus g of negative 5 all over 5 minus negative 5. So easy peasy, the denominator becomes a 10, and now we got to play around with that numerator. So off to the side, I need to find g of 5, and again, I'm going back to function g. So g of 5 is equal to the integral from 1 to 5 of f. So now here's where f comes into play. I need the area from 1 till 5. So 1, 2, 3, 4, 5. So I need this section. So I'm going to break that up into a rectangle and a triangle. Of course, you could just use a trapezoid, whatever works for you. So that's 1, 2, 3, 4, 5, 6, 7, 8. That has an area of 8. This is going to be 1/2 base times height. Base of 2, height of 4 would be 8, so half of that would be 4. So I would say this has an area of 12. Minus, now I need g of negative 5. So again, I'm just going to go plug that into my g function, g of negative 5. So I need the area from 1 to negative 5 of f of t dt. And now I'll notice that's backwards, so I'm going to negate that, flip those bounds. So from negative 5 to 1 of f of t dt. So if I look from negative 5, 1, 2, 3, 4, 5, till 1, I need this area to the x-axis. Okay, so this gets a little uglier. I got 2 triangles and a quarter circle. So I'm going to go my 1/2 base times heights of this big triangle. So that's 3 by 4 is 12, so that's a negative 6. I'm going to go to my next triangle. So that's a 1 by 2. So that's negative 1. And then I need a quarter circle. So I'm going to go 1/4 pi r squared. My radius is 2, so 2 squared is 4. So I'm going to say that's negative pi. Why are they negative? Because they're sitting below that x-axis. So if I combine those together, negative 6 and negative 1 make negative 7. So I have negative, this is negative 7 minus pi. So that negative will negate that to 7 plus pi. So I have 12 minus, this area is 7 plus pi. Now, again, I want to be clear, this is full credit. You do not have to add those together. If you have it written correctly, that's fine. If you want to add it together, that's also fine. I've got 5 minus pi over 10. Part B, find the instantaneous rate of change with respect to x at x equals 3, or state that it does not exist. So obviously, rate of change means take the derivative. The instantaneous means at this instant in time. So I'm deriving at a number. So I want g prime of 3 is basically what that question's asking. The rate of change is the derivative. The instantaneous is the instant you're going to plug in. So I need g prime of 3. So I'm first going to find g prime of x, and I am going to recall that g of x is equal to the integral from 1 to x of f of t dt. Now, this is a really nice topic. It's called that second fundamental. When I want to derive an integral, I derive this side to get g prime, and I derive this side. I do 2 things. I take that upper bound and substitute it in, so f of x, and then I multiply by the derivative of the upper bound that I circled times 1. So I know that g prime of x is equivalent to f of x, which is extremely nice because you happen to be staring at f of x. So the instantaneous g prime of 3 is then equivalent to f of 3. And if I just take a peek at that, f of 3 is equal to 4. On what open intervals, if any, is the graph of g concave up? So again, I'm going to highlight that key calculus term for me, concave up, and then I'm going to say of who, g. So I know I'm looking for g double prime to be greater than 0, would be concave up. And there's my justifying. I like to do that first and then go get the question. So if we just said g prime is equivalent to f, then g double prime, if I derive this side, is equal to the derivative of this side, which would be f prime of x. So if I want to know when G double prime is positive, I really want to know when F prime is positive. So if this is a graph of F and I want F prime, I'm looking at its slope. So I'm just looking to see when the slope is positive. So I'm just going to go left to right. Positive slope, negative slope, positive slope, zero slope. So I'm going to state those two intervals from -5 to -2 and from 0 to 3. And finally, part D, find all values of x where G has a critical point, period. I'm not going to read any further. I need to find when G has a critical point. So key calculus term again is critical point. The definition of a critical point is when your derivative equals 0. Now the derivative of who, again, it should be italicized for you, G. So the first thing that grader is going to want to see is when G prime of x equals 0. Now from our previous problems, we know that G prime is equivalent to F. So I need to state all values when G prime or F equals 0. And again, look how nice that is. Here's F. F is equal to 0 at -2 and at 1. So the first part of the question, I need -2 and 1. Now you'll notice it says classify, not one of them, classify each of those critical points as a min, a max, or a neither, and then justify why you picked that. Okay, so a min or a max is when your derivative changes from positive to negative or negative to positive. So again, of who? Of G. So I need to know what G prime slash F does at x equals -2. So if I go to x equals -2 and I look at G prime or F, so this happens to be a graph of F, what is F doing? Not what is F slope doing, what is F doing? F is below the x-axis, so it's negative, and then it remains below. So I'm going to say this is neither. Min or a max. F does not change signs. And then G prime slash F at x equals 1. So I'm going to go to 1. And I'm looking at F itself. F is below, and now F is above. So I would definitely say this is a min. Because G prime slash F changes from a negative to a positive. And there you have it.